So the general steps for these problems are to first find vi and vx. You have to resolve the velocity vector. Second, calculate the time going up using these variables. Third, calculate the height. Fourth, find the total time up in the air. And fifth, calculate the dx, how far it went along the ground. So our example, a cannon fires a cannonball at 540 meters per second at an angle of 9 degrees from the ground. We need to find the air time, how high it went, and how far away it hits. So I'm just going to leave a little room up here for our final answers because we don't want to be sloppy about this. So first things first, I'm going to resolve the vector into its x and y components. So here we have a cannonball fired at a certain angle from the ground. It's fired at 540 meters per second. First thing we need to do here is find our initial y velocity and our initial x velocity. What's going to be helpful is to remember that this is a triangle, and so it's helpful to label this as the hypotenuse, this as the adjacent side, and this as the opposite side, just so they can remember what side is what. So now our hypotenuse is our main vector, which is 540 meters per second. Our theta is 9 degrees. Our opposite side is our VIY, and our adjacent side is our VIX. Using the equations that we've used often before, h times sine of theta is the opposite, and h times the cosine of theta is the adjacent. So our opposite side is our VIY, and our adjacent side is our VIX. Let's make that clear. So when we solve for VIY, we get 84.5 meters per second. Our VIX is 533.4 meters per second. Now let's do a quick check to make sure this makes sense. Most of the velocity is going to be horizontal because it's only at a 9-degree angle. And so it does make sense that the VIX is going to be much greater than the VIY. Step 2, we go back and look at what we're supposed to do. Let's calculate the time going up using VIY, VFY, and G, gravity. So we're trying to find the time going upward. We know that our initial y velocity coming right out of the cannon is 84.5 meters per second. Why do we have to use the y? Because that is what's going to determine how long this thing is in the air. Our final y velocity is 0, and that's the whole point. This cannonball is going up, 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 up. It's slowing down, going upward. It's still moving sideways at the same speed, but then it gets to a certain point where it stops going up and then it starts to come back down. So since we're just looking at the time it takes to go up, our final velocity in the y direction is 0. And we know that it is accelerating in the y direction a negative 9.8 meters per second squared. That negative is very important. The cannonball is moving upward, but gravity is pulling downward. In fact, I'm going to highlight this right now just to make sure we remember. Okay. So now with the variables that we do have, So this is the equation we're going to use to solve for time. And just to make sure that we are all on the same page here, we're going to add our little y's. Everything is y's. We can't have any x's in there. So VFY is 0. A is negative 9.8 meters per second squared times time, which is what we're trying to figure out, plus VIY, which is 84.5 meters per second. So what we need to do is get this t by itself. So I'm going to start, since it's negative, adding 9.8 meters per second squared times t to both sides. So let's simulate that over here. 9.8 meters per second squared times t to this side and both sides. So what that's going to do, this will cancel out, and we're left with 9.8 meters per second squared times time is equal to 84.5 meters per second. We still don't have time solved, so let's do that. So we're going to divide, we need to get this t by itself, so we're going to divide both sides by 9.8 meters per second squared. So 9.8 meters per second squared cancel out on the left, and we found out that time is equal to 8.6, and meters cancels out, meters per second cancels out with those, and you get left with 1 seconds unit. So the time is equal to 8.6 seconds. So we've done 1 and 2. Let's go to 3. Check, check. And number 3. Calculate the height of the projectile using G, T, and VIY. Okay. So this is part 3. We want the height, and the height is dy. It's our question mark. So we just figured out time is 8.6 seconds. We know, of course, that AY is negative 9.8 meters per second squared. And our initial velocity in the y direction is 84.5 meters per second. AT squared plus VI times time. Now, just to make sure everything is the same, or we need to make sure that we're using only y variables. So anything that's a vector gets a y. That time is not a vector, so VIY. And we have dy, yes. Do we have AY? Yes. And do we have VIY? We do. So dy is equal to 1/2 times negative 9.8 meters per second squared, and don't forget that negative, times time, 8.6 seconds squared, and don't forget that either, plus 84.5 meters per second times time, 8.6. Okay. Now when we do this, the seconds get squared, and so that's going to end up canceling out those seconds. Meters per second here cancels out with, well, just the seconds cancels out. So everything's going to be meters when we're done. So dy will end up being 364.3 meters. And that's how high it goes. Okay? So that's one of our answers. Part 3 done. Part 4, total time in the air. We're just going to double the uptime. It's landing at the same height. That's exactly what this thing is doing. So part 4, the time in the air is our time up times 2. So our time in the air is 17.2 seconds. I'm done with that one. Let's go on to part 5. It's a horrible looking 5. calculate dx using the total time and vx. Okay, so finally we can talk about the x's. How far did it go along the ground? We want to find how far did it go, so that is dx. That is our question mark. Okay, so it was launched at an angle. How far did it go? We know vx, although we're going to look back up here to see what it was. It's 533.4 meters per second. We solved in part 1. And we know the time in the air, the total time in the air, because it goes all the way up and all the way back down. That was 17.2 seconds. Now we have distance, velocity, and time. So we will use v equals d over t. And just to make sure, put x's with all the vectors. So vx, 533.4 meters per second is equal to dx, which we don't know, divided by our 17.2 seconds. We solve for dx. And it went 9,174 meters. Okay, so we still haven't quite answered the questions. We found how we're going to, but we need to answer these questions. The air time. So we need to make sure this is nice and neat. Air time is equal to 17.2 seconds. How high it went. So we could just say height, 364.3 meters. And how far away it hits, that's our dx. So we could say our range, our distance, and this is our actual final answer here.